Live streaming is on.
Hello, everybody. Welcome to South Carolina Lugs, the Upstate Carolina Linux Users Group, and the Columbia Linux Users Group. And tonight we've got the Upstate Ruby Group. We're really glad to have everybody here. There's people. See, we actually have people. So tonight we've got Eric Anderson, who's rebooting the Upstate. Is it Upstate Ruby? Is that what it's called?
Yeah, Upstate Ruby. Pete ran it for a year. Still, sponsoring it and stuff, and just trying to see if there's some interest out there to do some stuff again. I don't know if it's going to be a monthly thing, quarterly thing, or we'll just keep crashing parties like this. We'll figure it out as we go.
So I'll let you take it over, Eric. Thanks for coming tonight, and I'm gonna
let me
disconnect and
share my screen.
And turn off.
Screen on.
Ooh, Inception.
All right, so I think my screen is sharing, but if I switch windows, does it?
Yep.
Stick to.
Yes.
Okay, so you can see that. All right. Okay. Hello, my name is Eric. Some of y'all know me already, but those who don't, I'm a developer here in the Upstate. Just always interested in different technologies. I do a lot of stuff with Ruby, so hence the Ruby connection. But MRSK is something that I'm hoping will be of interest to other folks. It's more about along the lines of Linux folks managing servers and that type of thing. So we'll see what y'all think of it. It's anyone here before I posted the announcement heard of it before? Okay, yeah, got some buzz.
A week. It was great. It was like a week before I heard it.
So yeah, it's something that's new. It's definitely different. So if you're looking for it to be like, oh, this is like X, but by someone else, it's definitely not going to replace. It's a tool in your toolbox, I guess, is what I'm getting at. Not a thing that's going to become your only tool. But anyway, so the basic format here is I do have a couple slides. I try to keep that to a minimum because no one really likes slides. But I did want to talk about what it is, what problems it's solving, and how is it solving that problem different than others. But then mostly just going to jump to some demos showing in action. Kind of that picture says 1,000 words. I guess a shell terminal says 1,000 words or something. So what is it? I did find some people refer to an acronym, but I think that's a backronym added later because it's not in the README or on the website, but I did see it, so I think I was so mostly ignore that. You can go with the acronym approach. Taxonomy approach here, it's a container deployment or container orchestration tool. Now, that might mean something to some folks in this crowd, might not others. I didn't want to necessarily assume. Hopefully, maybe some people are slotting that in their mind of, oh, that's like XYZ. But if not, we're going to do a quick bit of info on Docker and container orchestration. Anyone know why they call it Docker or containers, or why they have this little shipping container whale as their logo? What's the backstory for it? What's the inspiration for that? What's with the Docker?
Shipping containers.
Exactly, shipping containers. They were inspired by shipping containers. The way you move shipping containers around the world with boats, trains, trucks, cranes, and you largely don't care what's in it. It's a standard size, and that was their inspiration. They wanted before Docker. I'm sure some of y'all remember. You go to deploy a web app on a thing, and you might have a couple shorthands, a lamp stack, but then you're like, okay, well, what version of PHP, and is short tags enabled or not? And what extensions and what mod rewrite rules do we need to put? It's just a plethora of things. And the idea is just to move that to the developer to say, here's what this thing needs. And you can just run it, download it, and run it without caring about all those details. It could be implemented in PHP or Rust or whatever. You don't care. There's just HTTP traffic coming out of port 80. That's all you really care about. So it's sort of reduce that complexity, compress that complexity. It is a leaky abstraction, though, and what I mean by that is it's not always interchangeable. I said, well, we don't care as long as there's web coming out, but what about like database containers? I can't just swap a MariaDB database for a Postgres. They're different. I also need to configure things like what's the database user, what's the database password. So there's a certain amount of configuration. So there is some complexity still. Like, it's not like shipping containers where we really just don't care what's in it. And I don't know anything about logistics, but I imagine shipping containers, it's probably a leaky abstraction. They probably care if it's, fireworks or refrigerated stuff. But so there's some configuration. What volumes do we mount? Like what files do we need to mount onto the host system versus what's running in the container? So that type of stuff is something that Docker itself doesn't really address. Abstraction's also incomplete. We typically don't create a container that has everything, as your app, your database server, your everything you need to run an app. You typically do, here's the container for your app, and here's the container for your job server, and here's the container for your search engine. And the reason why is because those things have different needs. Web apps scale horizontally, databases scale vertically. So we need to deploy these different containers onto possibly many servers. Might be 5, it might be 500. And we need to coordinate these containers talking to each other. And all that Docker really doesn't address by itself. And that's where let's see. So the stupidest way to solve that is just SSH into each server, pull down the containers, run it with the relevant environment variables. But this is manual and error prone. So solution there is container orchestration or container deployment, where those configuration, that arrangement of different containers, how they talk to each other, is kind of bundled up in some configuration. Docker Compose is something by Docker. It's only a single system, so it's not really addressing all those missing pieces, but it is still getting that collection of containers up and running with a configuration. So that's along the lines of what we were looking for. Nice for development, but not really what we need. Docker Swarm is basically multi-server Docker Compose, so that's starting to get a little bit better. No one really, does anyone here use Docker Swarm today? Maybe they did once. Yeah, no one uses it. The vendor themselves, I think, have pretty much given up on it. And it's this kind of middle ground where it's not complex enough to do everything that like a big enterprise who has really hard needs has, but it's also still pretty complex. So it's not, not really addressing anyone's needs. There's a few others out there. Anyone use HashiCorp's Nomad or Apaches and Mesos? Yeah, no one uses those either. There's probably a big 800-pound gorilla that everyone can guess what everyone's focused on. Kubernetes as the container deployment, container orchestration tool. Developed by Google. It's based on an internal tool they had called Borg. Basically just add containers. And Kubernetes. Tons of support for it. Google themselves run the service. Amazon, Microsoft, DigitalOcean, everyone will run a Kubernetes cluster for you. So that's nice. There's also an open source option, or probably more than one, but SUSE's Rancher is open source. So this is all sounding pretty good. Solves our problem. Lots of options. Industry-wide support. And I think the general sense is if it works for Google's needs, it'll probably work for yours. So that's kind of on the positive. But I do have some nagging questions. Like, why do we need these cloud services to run a cluster for us? Why can't we just spin up some VMs and slap the open source Kubernetes in there? No, does anyone do that? Not use Rancher, not use a couple of people probably, but most people tend to opt for, running GKE or one of the others, or using Rancher. Even Rancher, how they make money, they're giving it away. They supposedly bought Rancher for $600 million. I don't know. There's a puzzle piece there missing for me, and the answer really is that Kubernetes is complicated. This was just off the top of my head. Some components of Kubernetes, I don't use it a lot, so I don't even know all the pieces of the puzzle. It keeps going on. For Google, that made sense. They're a big internet scale thing. They have lots of apps. So despite the fact of Kubernetes being complex, it still compresses that complexity for them. But does it for the rest of us? It may, the other side of, well, if it satisfies Google's needs, it must satisfy ours. The flip side of that is it probably satisfies a lot more needs that we don't even have, and we're getting a lot of complexity. And so we end up paying these commercial services to run it for a fee, which is, I mean, I guess fair trade. But they're going to add their proprietary layers on it, their integrations with their other services, and sort of start locking you into their cloud. Kind of that embrace extend strategy that I think us Linux folks are familiar with. So this is where 37 Signals, the creator of MRSK, found themselves at. They were using Amazon EKS, probably pretty happy with it. I mean, they were paying Amazon a little bit, but they wanted to leave the cloud. They wanted to get off Amazon because they figured out it's going to save them $7 million over 5 years to buy servers instead of running them. They contacted Rancher and said, well, hey, can y'all help us? We don't want to necessarily run it ourselves, the open source bare metal version. We want to focus on our projects, our service that our customers actually care about. And Rancher said, yeah, for $2 million a year, we can do it, which pretty much killed any motivation for moving off the cloud. They might as well just stick on Amazon. You could hire some Kubernetes experts who know how to run the bare metal version of it, and not just the GKS or whatever. GKE, I guess is what it's for. So you could hire some experts, but then, I guess your customers aren't paying you to run a Kubernetes cluster. They're paying you to solve some problem of theirs. And running a Kubernetes cluster, if it helps you, it's a cost you might be willing to consume. But DHH, the creator of MRSK, it's sort of a polar person. People have hate or love relationships on him, but regardless, he's sort of a contrarian. He given the options that the industry gives him, back when he was creating Rails, it was, well, you should use Spring and Java and all that. And he's like, no, we're not going to do that. The industry is now giving him an option where you can run on the cloud, you can pay for some expensive enterprise contract with Rancher, or you can hire a bunch of Kubernetes experts. So this is where MRSK comes in. MRSK is simpler. It does less. If you're looking for every feature tick box that Kubernetes does, then it's not going to hit that. But the question is, does it hit what you need? And if there's some aspect, some little checkbox that you do need that it doesn't do, can you build on top of MRSK? Kind of build up versus having that kitchen sink you're rummaging through. Just size comparison, MRSK is less than 6,000 lines of code, so it's something you can read on a lazy Sunday morning. By Kubernetes, just the Go code, and there's other languages in there, and that's just base Kubernetes. That's not Rancher on top or anything else. 4 million lines of code. So there's a lot more complexity. Yes, it's going to do more, but let's see. Other focuses of MRSK is any cloud or multiple clouds or no cloud. That's, again, coming from 37 Signals' goal of getting off the cloud. And they also are intentionally imperative versus the kind of declarative state reconciliation that Swarm and Kubernetes do, where with those systems, you say, well, here's what I want, and I want you to monitor everything and kind of self-heal and all that. And that sounds really cool, but that's, again, complexity. Is maybe just having a little redundancy good enough? If you have, 300 web instances, if we lose one, do we need it to self-heal? Is that okay? Or could that just be something we, fix when we come in on Monday morning, and only if 20 of them go down do we get alerted or, look into. And honestly, even if you're using Kubernetes, if that happens, you're going to be alerted because, if a bunch of things going down, that's probably not good. Let's see. So I mentioned kind of the stupid way to use Docker and solve that missing gap of what Docker is. That's essentially what MRSK does. It shells into your servers, installs the stuff you need, and gets it running. There's some other pieces of it we'll see in the demo, but that's essentially the long and short of its goal. There's no agents on the server, doing state reconciliation. There's no database or no Etsy database. The only thing you really need is what are the IPs that you're using to deploy your stuff to. And You need a container registry to store your containers that are going to be deployed, and a machine deployed from. It could be your developer workstation, CI system, GitHub Actions, whatever. But the basic process is it's going to show in each one. It's not assuming you have anything installed, so just a base Ubuntu, Red Hat core, whatever will work. It's going to put Docker on there. It'll install what's called accessories, which is like your database, search engines, those type of containers on the servers that need those. It's going to build the application on that machine that you're building. That could be your local dev machine if this is just like a basic thing that doesn't need a CI system, or it could be, like I said, a GitHub action that's running MRSK.
And when you say it's SSHing to each, you're talking about each container or each server that has containers?
So it's connecting to each server and going to install the Docker and the containers to run it. It does put traffic in front of the containers for the web processes. And the only goal of that is to make it a zero downtime deployment. The idea is that when it goes to boot up that next version, it's going to wait for it to get up, going to do health checks, make sure, okay, yeah, it's up. And then it's going to kind of just hold those requests and traffic for a second while it switches out the container, so you get a zero downtime deploy. That's on the slide, so we're just going to jump right into the action to see how this works. So I have a couple things I want to cover. One is if you're just looking to get this installed, let me bump up the size a little bit. If you're already in a Ruby world, you probably already got Ruby, gems, gem install Ruby. This is the Python equivalent of pip install or whatever framework. That's a great way to do it if you already got Ruby. If you don't, you can alias the MRSK command to this big long Docker string. This is going to run MRSK in a Docker container, so you don't even have to install Ruby if you don't want to. It's it's technically installed. It's in a Docker container, but it's not anything you have to manage. Now to get it set up on a project, let's see. So I'm just going to create a blank directory called test, and we're just, how do you make it bigger on this show? Oh, that's very slow. Okay, any better? One more, maybe. Okay. So MRSK init, sorry. So this is the idea is in this directory you'd have your project you're wanting to deploy via MRSK. Right now I have a blank, and the whole point is so you can just see what MRSK is going to do to this. It's going to put a couple things in there. It's going to put a configuration file under the config directory, which is nice because I don't know about you, but I can't stand the way everything puts it in the root directory. So that's nice. That's essentially the Docker Compose or Docker Swarm equivalent. It's going to tell you what that orchestration is. If you don't already have one, it's going to put a .env file. That's where you're going to keep your secrets. That is not to go into your repository, so you want to put that in your git ignore. And then lastly, it has some hooks that will run when certain actions happen. So you can see the actions here. It gives you some sample ones, and their samples aren't just hello world. They're actually sort of useful. Like, let's see, what is it? Yeah, it's check and make sure did you actually commit all your code, your Git code and stuff. So I wouldn't necessarily delete these hooks right away. Look to see if they're useful to you. It does have like just a dummy here. I don't know if let's see. Just echoing stuff out after it's deployed, but you could say send that to a Slack channel or something to notify that. They're just shell scripts, so you can do what you want. There's a couple variables that get set to communicate what happened, and so that's sort of the getting set up on it. We're gonna do a hello world one here. Yeah, I'll do hello world here. Put this up. Okay, so what I wanted to do was just start off with a web app that does nothing at all, really, other than return hello world. So you can focus on just the MRSK aspects. So obviously, it's not a realistic app, but and that's the, so let's see. Let me kind of just see. So I'm going to run it here real quick, and then we'll go to my web browser here on 7001,000. And that's all it does. Yeah, you can hit any path you want. So bar PAAS, same thing. And if we look at the code for this, it's implemented in Crystal because it's I specifically chose this because I didn't want a runtime. I wanted something I compile to a static binary. Again, and the idea of keeping it as simple as possible. And in Crystal, it's a nice one-liner here of create a web server, have it on each request, respond with hello world, and it's going to listen on port 3000. That's all there is to it. If we look at our Docker file, pretty simple here. We're going to use the Alpine container, keep it nice and light. The curl's probably a little weird. We'll come back to that. And other than that, basically, we're just going to run our hello app on there. And then our deploy file, which I kind of already brought up, we're going to give it a server, which that's going to actually spin up one. So kind of you can see there's no cards under the sleeve. This is just over on Hetzner, which is sort of just a really, really cheap VM service. So you can just see I'm just selecting the base Ubuntu. We'll just do their smallest little thing of like half a cent an hour. We'll give it a firewall though, just keep bad people away. And we'll name this hello. And this usually takes like 10 seconds or so. So we're spinning up a little server. We got an IP here. Let's go ahead and copy that into our configuration. Get this commit am stuff. So we committed it, and now we're going to MRSK setup. Since I didn't put the deploy in that config directory, I have to specify the deploy file. Obviously, just because I only have a few files, I didn't bother creating a directory. See, did it spin that up? Yeah, it spun that up. So let's just see if this works. So you can kind of see what it does. It has a deploy lock that it uses to try to prevent multiple interacting deploys from different systems. And I don't know how fast this internet is, so we'll see. But it shouldn't.
Does it queue it?
Huh?
So if more people deploy, does it queue your deploy?
No, it's going to just say you can't acquire the lock or something along those lines. It should be normally very fast. This is where demo gods, do we pray or not?
That first word is acquiring.
Yep.
Come on. I wonder why it's not. See, I got the IP. I committed. Let's see where it's.
How did you set up your SSH service and manage all that before you?
Yeah, so one of the things when I was kicking off that server, I did say I already have my SSH key on Hetzner, and I told it to use a particular key. So I should already have that. Oh, I know why. Okay, sorry. I used a pre-done firewall. I can use IP.com, which was just pointed to my home IP address, so only I could access the SSH. So we're just going to add that and apply the firewall changes. All right, now it should. There we go. So you can see here it runs Docker V just to see if Docker's installed. The failed here doesn't necessarily mean bad things; it just means that command failed. So the whole command will fail if things aren't going well. It looks to see if we're running as root, so that way we know if we can install Docker or not. If you aren't, then you may have to bootstrap Docker yourself. It usually takes like 30 seconds or something to install Docker, so that's what. And the nice thing about seeing these commands is if something goes wrong, you can largely just shell into it and run the commands. It's no black box. So you can see here it's going through, it's building that Docker container. There wasn't much to it, just adding that file. The reason for that curl command, that comes into the health check it's going to do once it gets this done. You can run any command you want as a health check, but there's a default health check of running curl on your web server. So you need to put that in the container in order for it to be able to run that program. So even though my web server didn't need curl, we had to add that just for the health checks. But you can, if you're doing health checks another way, maybe you have wget already installed. Yeah, you can run whatever command you want.
Well, curl is also used to install Docker.
Oh yeah. Well, but that's on the base system, Ubuntu.
Oh, okay.
So yeah.
Yep, right.
So, but you can see here it's setting up traffic. That load balancer here, you can see it's running the health check. It's you can cut down on this logging if you want. There's log levels. I sort of like it all because then if something goes wrong, I'm gonna ignore it most of the time. But if something goes wrong, I don't want to. I want to see it the first time through. Yeah. So there you go, finished. And now let's go to that IP. Let's see, servers there, and it's going to complain because there's no cert. This is all cert, but then it's slightly off the edge. But you get the idea. There's a hello world there, so it deployed. Now we're gonna kind of do some more fun stuff with it with this hello world, but I'm actually going to switch to a different directory. And again, the nice thing about MRSK is it doesn't really have any state or concept of what. So even though I switch to a different directory with a different Git repo, it's fine. It's so this is the same program as before. The Docker deploy here is largely the same, except for I put this little extra line here, build or multi-arc faults. Get to that in a second. And the big difference I made is instead of pre-compiling that Crystal program to a binary and just adding it, we're going to do it more the proper way, where we're going to create a temporary container, build container, do the compile during the build process, and then we'll copy it from that temp container to our final container. And not only is this the better way to do it, but it's going to allow us to show off a feature. So let's see. So yeah, I changed this to say hello build is about all. So what we're going to do is switch to that hello build directory. Oh yeah. And by the way, later demo we're going to show where you don't necessarily have to hard code the IP address. I'm just again trying to keep it to hello world for this first little demo. So there we go. You don't have to absolutely commit. If you don't commit, it will basically use the commit hash as the version plus the word like uncommitted plus a random number. So you probably always want to commit before doing so. Just commit stuff. And then we're going to do MRSK. Now, once you've deployed though, you don't. So I did MRSK setup the first time, and that's going to bootstrap it with the with Docker as well as get everything done. There's once you've bootstrapped it, you can use MRSK deploy, which is sort of the full deploy, and then there's MRSK redeploy, which skips the steps, doesn't check to make sure traffic's running and that type of thing. So I think I can just use redeploy. We'll see. Redeploy if I can spell correctly. So this will take slightly longer because I'll need to compile actually I think it cached it because of what I was Docker caches stuff, and so there it goes. So this will take about 30 seconds on my machine to compile. Crystal is not the fastest compiling, but we're still creating a static binary final release, so that way there's no dynamic libraries I need to add to the container. Let's see. There we go. So it's pushing that up to the same. I'm pushing it to the same registry, so it's just gonna work again. Push.
So it's not building on the Hexagon server.
No, it's building on my laptop here. And again, you could, it's building on a machine. I'm using my laptop. It could be your CI system. It could be GitHub Actions or whatever. But going through, doing its thing, finished a little bit faster that time, even though we added the 30 seconds compile because we skipped some steps with that redeploy. And now I should be able to go to here and see it's hello build slightly cut off because we got that new version. Now, the reason why I wanted to build it in Docker, though, is for a specific purpose. We're going to come over here and add another server real quick. And we're going to pretend we're going multi-region here. And there's a specific reason is because what we want to do is pick an ARM machine. Runs a little cheaper. You get 4 gig machine for the same price. So we're going to spin that up to have a second hello server going. Oh, I didn't give it a good name, and I didn't put the firewall on it, but that's okay. That's fine. All right, so we're going to add our other server here, commit it, and let's see real quick. Yeah, that's fine. Okay, so that's up and running. So now I'm going to deploy again, but can anyone take a guess as to what problem I'm sort of hitting at here, remembering the little configuration of multi-arc faults?
ARM CPU and regular CPU.
Yeah, exactly. So I have one server I booted as Intel. I have another that's ARM, and I'm compiling machine code here. This machine here I'm compiling it on is Intel. And I could have it reversed. I could have a server out there that's Intel. Maybe I'm using Apple Silicon. But the nice thing is if we take this out, and so we kind of do it the default way MRSK does it. Again, we won't redeploy because the second server hasn't been set up. So do MRSK setup. So it's going to go on each one. First one, it's going to see Docker's already there, but the second one, no Docker. So it's going to go and install that, kind of like before, get that server set up. And again, this was just a server I spun up with no prep. I said use Ubuntu, and you can use whatever. It's using this command here, get Docker, pipe it to a shell. So that works with like any Linux distribution, basically. So whatever you want to use as your host machine is fine. But the kind of the punchline here is MRSK by default will do multi-architecture. So it's actually going to create 2 different containers. By me saying faults, I just told it not to. Now, that does make it slower because I'm building 2 different containers. How it does that is it boots up QEMU to compile that ARM on my machine, which is really slow to compile things. So you'll see here the first one. Oh, I meant to change the text to the hello, but that's all right. You'll see here that the first one will get done in the 30 seconds that it took before, but the second one to build that second machine takes a little bit longer. Actually, it didn't seem to take too much longer. Make sure everything got done right. Should be fun now. I guess we're going to find out here in a second. Okay, yeah, you're right. It did cache them. So you can see here the ARM and the ARM and the AMD build. They were cached on my machine probably from testing earlier. But no, if they weren't cached, it would have taken about 30 seconds to compile the Intel one and about like 2.5 minutes to compile the ARM one. But now we come over here and hit our ARM machine and say it's okay, that's HTTP, and we got our hello build again, and our first one still works as well. So we got one set of source code that was just, we didn't care about what architecture it is. Now, if you don't like that performance hit, that's going to kind of vary depending on what you're doing, right? Like if you're doing a PHP app that's interpreted, it's going to grab those 2 different architecture PHP containers, pull them down, but it's not compiling anything. But in this case, it's compiling, or maybe you're compiling assets like style sheets, JavaScript. That takes some CPU, and to do that on emulated architecture is going to take more time. So if you don't want to do that, let's see, arc you can actually configure it to have say, okay, ARM, this is sort of assuming a Mac setup. So ARM is going to compile locally, but, Intel, go to this machine. So you can have a compile server that's the right architecture so that way it's much faster. You'll send it off to that machine. And if you don't care about architecture, if you're like, I'm developing on Intel, I'm deploying to Intel, you can go back to that architecture faults flag and it won't do anything with architecture. But it's nice that it out of the box is going to do the right thing for architecture. Let's see. A few more things before we give Hello World our goodbye. We can, I think it's audit. Sorry, I forgot to do my audit. There's an audit log on each server kept as to who my username is me. So, but it would say Eric or whatever if you named it something reasonable. But it's telling you who deployed it when. So you got a little bit of a trail of what's been released when. And this is per server. So you can see like the second one we booted up really just has that first deploy, while the first one has a couple more. We can, what's that? I gotta remember the commands here. Anytime you want, you can just MRSK, MRSK help, and you can, I think it's app is zic. Yeah, okay. So I could say app is zic, we'll just get the date. So this is going to connect to each server and just run whatever command we want. If we wanted to only run it on one, we could give it I think it's dash primary option. I think it does the first one. Yeah, so I only ran it one. We can also do, let me up real quick. Yeah, so we can give it the dash I option, and instead of date, we'll give it bash. I don't know if I'll just try bash. I don't know if that's pbim bash or what, but that's probably because I'm doing, let's try the shell. So now I have a shell on that interactive shell. It's actually launching its own, like another container, temporary container versus messing with the container that's deployed and serving your app. So if I go and install Vim and edit files, as soon as I exit out, that container is gone. If you do want to pop in, what's that?
You still have access to the logs and everything on your computer? The application logs? Yeah, from that container, is it all still connected together?
Yeah, so I'm going to show some log. Unfortunately, this app I made doesn't have any logging. So, but you can merge traffic logs. You can grab the traffic logs. That's the HTTP proxy, and there's another one for app to get the app logs. You can grep for stuff if you're looking for something specific, like a specific request ID. Now, of course, you can set. There's nothing to stop you from sending your logs, to FluentD, which goes to an elk stack and all that, But out of the box, yeah, it's the logs for your application are going to be available, and you can tail them too. So like I can put a -T on here. I think it's maybe I want -T. It may be only on the app log. Yeah, it must be only on the app logs that you can do that. Back to the exec, I can do there's a reuse switch that will connect in. I did bash again. And that connects in before, just like before, except for it's actually connecting to the container. So that's running our app. So we can see it's in the process list here. So like if I killed that, it would kill our service. So if you do need to get into the container, maybe to do some debugging, you can, or you can, have that throwaway container, whichever way you prefer it. Let's see. What we're going to do is go ahead and kill off at least our German server here. Copy. So I had a couple different versions on here. If we want to roll back to a previous version, if you type MRSK containers, that is container. Help. This is why I should have written down the commands and just copied and pasted them. But accessories, apps, might be an app. Yeah, app container. Sorry. So app containers, and so I'm using that non-standard location. Oh, I deleted that one server. Delete it out here because it's trying to. So it's showing you the 3 containers we deployed. You know, the original Hello World and then the 2 Hello builds. It keeps the last, so many. You can configure how many of the containers on the server. If you want to go back to the one from last year, you can do that still. You can reach out to the registry and download it. But the nice thing about this is if you just need to roll back to the last version, it doesn't have to download it or build anything. It's just going to swap those containers out. So we'll just go back to our original. So we'll do, I think it's, rollback, sorry. Couldn't remember the. And what we want to do is grab the container ID here. Let's see. We grab the oldest one that just said Hello World. So that's going to go out there, and it doesn't need to bother with. So it's in 6 seconds there. It just went and swapped out those containers. And if we come over here, it should be back to Hello World from that. I think that's the most we can do with Hello World. So we're going to now switch to something a little bit more realistic. Something with a persistent storage, database logs, some of those things.
But before you go any further,
okay.
Any questions so far?
Yeah, sorry. My wife tells me I go 90 miles an hour, and so feel free to interrupt me at any point.
I have a question. The Trafic, is it load balancing between those different servers you have running, or is it just one on each?
So that's going to be up to your particular goals. The general method that I think the MRSK developers intend is you're going to get your cloud provider to provide a load balancer in front of those. So that's really more part of your infrastructure Terraform configuration that you're going to say, well, here are my servers. You're going to spin up the servers and you're going to load balance between them. And that's also probably where you're going to terminate your SSL. And then your servers themselves will probably live in a private network that's going to be talking to those load balancers. But if you search the forums on MRSK, there's kind of recipes where someone said, okay, well, I'm just doing a single server because it's just some demo stuff, but I want to use MRSK anyway. And I want to put Let's Encrypt on there. And so they have, there's some pass-through stuff that you can pass through to traffic to configure it and get Let's Encrypt going on a particular server if you want, or other methods of doing that. Or a load balancer could be an accessory, just like a database we're going to boot up, for our app to talk to. We could have, instead of using the load balancer provided by the cloud, we say, well, this here is going to be on this IP is going to be our load balancer, and we're going to run it ourselves, using whatever. So that's sort of up to outside the purview of MRSK itself.
You may get into this. What about configuring multiple environments?
So MRSK has and I'm not going to actually. That's a good question because my demos don't actually cover this. Although, if you go to the
repeat the question.
Oh, sorry. Yeah.
Straight.
So if you, the question was, what if you have multiple environments, staging, production, that type of thing, or maybe you have, you have your Azure environment and your AWS. You want to, maybe you use MRSK to deploy bare metal for most stuff, but then you have a destination of cloud stuff for that heavy traffic season where you need the extra cloud. So you're kind of doing a little bit of each of written servers and bind servers. So it has this concept of destination. You give it -D option, and so that config file was called config.yaml. If I said -D production, it's going to look for config.production.yaml, but it's going to merge it with config.yaml. So your base configuration that's shared by everyone can be in config.yaml, and then maybe just your IPs that change or whatever production specific thing. The same with your secrets, which we didn't really talk a ton about there. You can see here I have a registry key, and by the way, I'm going to delete this before y'all. Let's see.
That is the password, or that is a reference to the password?
That's a reference. Let's see. .env. So that .env file on that hello, that was the only secret I had in there. And that goes to that throwaway Docker Hub account that I'm pushing up as my registry. That also has the same deploy thing. So .env is your base one, but you can have .env.production, .env.staging. And it's up to you to define what a destination means. Is that different environments for the same app? Is that different clouds? Whatever. It's just going to be a destination from its perspective.
Thanks.
Yeah.
So you answered this partially. The registry you're using is Docker.
Mhm.
Do you use a local registry?
I don't, but you can use whatever you want. Let's see.
Local registry.
Yeah.
I'm repeating the question.
Okay. Yeah. Not finding it, just doing a search. But in that configuration, if you want to use a specific cloud provider's registry, you can do that. If you want to run your own registry, there's a Docker container out there for it. It's open source, so you can just run your own registry. Let's see. Yeah, here it is. So you can see here, registry in addition to the password, there's registry.digitalocean.com. So and that's probably where if you got some proprietary software, Docker Hub will do private stuff too. But if you already got all your stuff in DigitalOcean or whatever, and you want to have all, because it's probably going to move your containers fastest if you're doing it local. So yeah, you can do that. Let's see. Any other?
How is this escalating your root to install Docker and you just put the button to start a server? Is it doing something, or am I just?
So the only thing Hetzner did for me is in that config screen, I told it to use I'd already pre-uploaded my SSH key, and so I told it to use that. MRSK is by default going to log in as root, but if you want, you can set a different user. Let's see if I can find that real quick. Oh, I think I passed it. So here, SSH user app. The only downside to that is it's not going to be able to bootstrap Docker because that requires the root access. But there's nothing to stop you from using Ansible or whatever to, get Docker installed that way. And then from that point on, now you're just going to create it. Maybe use Ansible to create an app user, and that way it's not running as root. That.
This is probably not first created then. So your host is escalating your SSH key in your root.
Yeah. So Hetzner when it booted up that server, it put my SSH key on there. So you're gonna need some kind of initial access, and most cloud providers provide some way to do that. And if you're using bare metal, you probably have some way to do that as well.
But the MRSK config had that SSH key and all that sort of stuff.
It's just part of my
in your config.
That's part of my SSH, home
Right.
SSH settings. I had a private key, and Hetzner put the public key on there for me.
But you told the MRSK config what that was.
No, because it's just SSH. It's just calling SSH. All it's using is regular SSH.
Just gonna run down the keychain.
Yeah.
You just whatever you're logging on, right?
What's that?
You just do whatever you're logging on.
Yeah. It's gonna follow whatever your user environment. And then of course, if you're running this on like GitHub's actions or something like that, you're gonna need to make sure to set up that SSH keychain, for that as well.
So I saw some logging, but can you do like log streaming or like follow the logs?
You couldn't actually for traffic, which I thought was interesting. But yeah, I'm gonna with the next example, we'll actually have logs, and so we'll show the logs from the app.
Want to ask online?
Any questions online? Something about Podman. Yeah, it does only use Docker currently. There's no real reason why you couldn't use like Firecracker or something like that. In theory, it might require some modifications to MRSK itself. I'm sure they'd be open to that. They're just sticking with kind of standard works
Well,
for
they're
them.
opinionated, right? I mean, all this is opinionated, right?
Yeah. Okay, so pop on over to the next demo. We're ready for that.
Thank you.
All right. So let's see. So for we're going to deploy a WordPress site, which WordPress is sort of a bad example of this because WordPress isn't made for containers. It self-modifies itself, but that's fine because that gives us some things to talk about. So this isn't necessarily the suggested way to deploy WordPress. This is using WordPress to demonstrate features of MRSK. So we got our service here. I'm going to go ahead and do that multi-arc fault so we're not building two containers. Here's like a very basic idea of how to not have IPs hard-coded in there. Since I'm using Headstone, there's a command line hcloud there, and I'm just grabbing the first IP that happens to be in my account there. So that obviously that's overly simplistic. Let me shut down that other server. Let's see. But what this also shows is this syntax here between these brackets. That's Ruby's called ERB. So basically, this is Ruby code running there, and it can generate any kind of like PHP does. So this equal sign says put it out here. So I'm still going to be on a single host for this demo because WordPress is sort of best for that. Again, but you could make that complicated or have a library that's figuring out what the IPs are and pumping it into there. Still got the same registry. Because WordPress self-modifies, we're going to set up volumes. So that way, if we deploy a new version, it doesn't wipe out all of our customizations. We're also going to modify the health check. It by default hits the /up URL, which Rails 7.1 will make that available just by default. But we're just going to hit the root because that we're also looking for is a 200. So you probably if you're doing a real custom app, you'd probably want a specific endpoint for that. But now we're going to use secrets a lot more. We need to tell WordPress where the database is, and since we're using the same host, we'll just use that same IP variable. Some other stuff. WordPress has a whole lot of things for it. Actually, let me just bring up the .env. So you can see here, there's a MRSK password, there's our database password, and then there's all of WordPress's secrets that they need. There's instructions on how to get these for WordPress. So, it's just generated. But then the more important part here is our first accessory. We're going to use MariaDB, which is MySQL basically. You can specify an IP address, or you can also, for any accessory, specify roles. There's a default role of web, but we'll see in the next demo other roles. But so basically, I'm like saying use the same IP as the web's using, since I'm just got one server. Just save me. I could have just put the IP variable, but I just wanted to show the role. The roles is like if you wanted to put a monitoring on every web thing to report to your elk stack. Like so you'd say, okay, on the web role and on the job role, put this monitoring accessory. So kind of a shortcut there. If you have not secrets, you have env variables that aren't secret, you can just put them here in this clear group, and then the secret ones are just listed there. Directories works pretty much the same way that volumes did. The only difference is it basically prefixes it with PWD and the name of the accessory. So that way it's like namespacing your different accessories. So if you had other accessories, Redis or whatever, each one's volumes kind of going into a specific directory. Does it all kind of make sense there?
And you could have said put MariaDB on a different server.
Yeah, I could have. I'm just doing this, for kind of simplicity. But I could have easily, just by changing that role, get rid of that and say, I think it's host and then the IP that I want for that host. And we're going to see that with that final demo. So now our Docker file is ridiculously stupid because we're just going to say from the WordPress, because I don't actually have if you were customizing WordPress, right, you'd actually have it local and have it build, but I'm not going to customize anything. So, and I'll just for fun, I did make a Terraform file here versus having to click through the, this is specific to a particular cloud, but you can see I'm basically going to do the same thing where boot up a server, their smallest server, use my key, here's the firewall to use, only allow SSH from our current IP. So, that WordPress directory. So first let's spin up that server. That should just take a second. And this doesn't have anything really to do with MRSK. I just, as a good practice, you probably want infrastructure as code, not clicking through the cloud interface. Okay, so 11 seconds later, we got a server. So now we're going to do MRSK setup and our deploy file. Hitster tends to like reuse the IP if you just deleted a server. So because I just had the IP on a different server, it's complaining. We'll just delete my known host. All right. So we're going to go out there. Same steps before. We're going to install Docker. It'll take like 30 seconds or so. It's going to build that WordPress container. But actually, before it builds the WordPress container, it's going to install that accessory, that MariaDB. And let me look at something real quick while that's running. No, I didn't do that. There was another little demo-y thing I was going to show you, but I didn't do it right, so that's all right. All right, so you can see here it's running MariaDB. This could have been a different server. We're just happened to put it on the same server. Now it's going to build that WordPress. It's going to push it up. Hopefully your internet connection's reasonably fast to push this up.
Is everything that's not the main app considered an accessory, or can you have like multiple?
Yeah. So everything that is the app needs, like generally your those persistent services are going to be accessory. If you were doing like a microservices architecture, probably each app would be have their own MRSK configuration to deploy to their own set of servers, because that's the whole point of the microservices app, right, is each one's responsible for their own thing. And then if they share accessories, well, then, I don't know, you could either have just something just for that, or, at that point, that might be something where you wanted to use a hosted database. This doesn't stop you from using hosted databases. If you're like, yeah, I want to use this to deploy my web apps, but I'm going to stick to a managed solution for SQL or whatever, you can do that. No big deal. All right, so it deployed us. Notice I didn't have to put the IP in there because remember my little command there grabbed it. So there we got our old WordPress up and running. And we'll say this is for MRSK. Is this a nice password here? Copy. MRSK@example.com. Install. Again. And so there you got WordPress. You can visit the site, that type of thing. Want to log into the server though itself to show some things. So grab this IP. So remember before I just put I just put the directory here, database goes to varlib MySQL. So what it did is it created under my PWD, whatever user I'm deploying to, which in this case is root, it created a blog-MariaDB. Blog's the name of my service that I gave it. MariaDB is the name of the accessory. So under here you have that database that I specified. And so this is where all the MySQL files that you want to persist go. And then I also I did a volume for for the WordPress themselves, because that whole the fact that WordPress is sort of self-modifying, and so that's where all those files are at. To your log question, we can do MRSK logs. This should put up the Apache logs for because that's what the WordPress is using. It's just got Apache embedded in there, and so there you can see the Apache logs for where they're including the health checks. You can see from this curl. We can put a -T on there. I think that was T. F follow. Yeah, so let me. So you can see here as the additional requests come in here, it's going to output it. Like I said, you can kind of grep for things if you're looking for a specific request ID.
Is your web browser an iPhone?
No, it's just probably hitting. It's probably getting random traffic.
Okay. Already.
Yeah. Yeah. WordPress gets attacked quickly. So the one thing I was going to show that I didn't quite, but I'll just at least mention it, is I meant to put an old version of MariaDB on there because I wanted to show updating. MariaDB has this auto upgrade true. Oh, if I put the tag on here, so where'd my mouse go? For old version, whatever that is. And then later I decide, okay, we want to upgrade it, so to new version. If you type MRSK accessory reboot, I think it is. Let me check that. Yeah, reboot. We'll go ahead and run it just to see, but it's gonna. Oh, which service? MariaDB. So if I had correctly what I meant to do, which was have an old version on there initially, it's going to go stop that and boot up whatever I'm now configured to. So that would be a way to upgrade those accessories. But that very much depends upon the accessory you're doing. MariaDB does that auto upgrade. I don't think Postgres does, but there's third-party ones out there that probably would. Any question?
Redeploy doesn't do that by default.
No. So deploy and redeploy just deploy your app. They don't really kind of mess with the accessories after the initial setup. In fact, if you run setup again, it's going to complain because it's going to say like that's part of the initial bootstrapping and setting up your accessories. After that, you're really just concerned with your app. And if you want to interact with the accessories, there's specific accessory commands like this reboot.
So say you have multiple IP addresses in there. Does the accessories only deploy one time, or is it what it do for each?
Yeah, it would do it for each. And again, that's where we have a leaky abstraction of not all containers could go to each. They don't all scale horizontally, but like MongoDB, yeah, you could potentially do that. If you were doing something like a high availability Postgres, you would really have two different accessories. You'd have one for your primary, and then you'd have a different one for your read replicas. And that those read replicas you might scale horizontally and maybe even across other regions. So it gets a little bit specific to your needs. Any others? All right.
Can you do reboot without doing setup? Like, will it complain?
I don't know. We can find out. So we can say MRSK delete. I think it's delete. Remove. That's it. Not delete. So this will, if you've tried MRSK and you just find you didn't like it, but you want to keep your servers, this will go and remove all what MRSK has done, all the containers, everything. It doesn't remove Docker, but other than that, it does check though. It's getting cut off here a little bit, but it's checking. Hey, do you sure you want to delete this database? Because that's an accessory that has persistent storage, and we're going to delete all that. So I say yes. And so now it's back to vanilla server. So like if I did,
It says your site can't be reached no more.
You're the iPhone.
No, it's Andrew. I lie.
So yeah, let's see.
This is way too easy.
I don't know what it's going to do.
I'll just add some compilation in
it seemed to, I guess, because Docker was already on there, and it seemed to basically set up that. So it's not really much. There's a accessory boot, I think, that you would normally do to. We'll see it actually in the next one here. So we'll just. I think that's all for that demo. So we got one more.
So I guess you could run redeploy too.
What? Redeploy would probably get problems because then traffic and stuff isn't. Let's see. You can always find out. Redeploy.
I was wondering if you could just always redeploy instead of set up, deploy.
Yeah, so generally, if you're not changing MRSK, you're not changing your infrastructure, yeah, pretty much what you're generally going to want to do is redeploy. And that's going to be a little bit faster because it's going to skip some steps. It's pulling down the container. Oh, there also is a -P option where, like, if your CI system has already built your container, so no need to rebuild it, you can just say, I think P stands for pull or something. You can just say pull down the container that's already in the registry. No need to build your container here. Yeah, I don't even understand this because I did redeploy, so you'd think that would have just failed completely. It launched the WordPress. I don't know if it has traffic though in front of it. I don't know if we can see. Let's see. Yeah. Okay. So it launched the app, but then didn't have the HTTP proxy in front of it. So yeah, wouldn't probably recommend that. And you could easily do your own test and run the right command if you wanted. All right. So for the last demo, let me terraform this.
I was just trying to compare to like Docker compose where you change anything and you just do up again and it changes it for you.
Yeah. Yeah, I don't think it's not. If you look, like I said, it's not much source code. If you look at the source code, it's using that. I don't know if you're familiar with Thor. It's used by Rails to generate stuff. It's using that, and so it's largely like when you run MRSK setup, it's running another another command called bootstrap, and then it's running. So you can just look in the source code and see that this is really just a collection of running these commands. So there's not a ton of intelligence built into that.
Have any way one of the things that who loves to do is having control plane across all the machines. There's different Docker instances you want to see all the apps that are running all together. You have a way of doing that.
Not with MRSK. Now, there's nothing to stop you from putting whatever monitoring you want on there. And even if like Kubernetes will do cool auto healing thing where it will detect a container a VM has died and launch that container on another thing, you could potentially do something like that with this here. You could have monitoring that then spins up another server, another VM, and runs MRSK deploy. Once you're starting to get to that, though, then you might say maybe Kubernetes is what I want for this app.
I was trying to see if there was some way for like do monitoring across multiple VMs so what was all that.
Is there like a status?
Oh, I got what you're saying.
Running applications, basically doing a PS.
Okay, I got what you're saying. Yeah, so there's I just destroyed it, but we'll show on the next one. There's a MRSK details that shows details about all the containers that are running on it, and so it's going to shell into each one and get info about it. And I think there's also like a MRSK traffic details to get specific details about traffic too. So yeah, there is some of that. Let's see. So next thing we're going to do is an actual Rails project. We did PHP, we did Crystal. And this one versus with WordPress, I sort of cheated and just said from WordPress. And we're going to do Mastodon, run our own microblogging, I guess, join the Fediverse or whatever they call it. And I wanted to try to make this one a little bit more realistic, multi-servers and that type of thing. So I'm going, because I'm using their Docker file and it's not thin. So I'm going to actually go ahead and start this running and then we're going to talk about it. So let me just config infrastructure, form apply. So as you can see, we're starting up a few more things than before. And I'm gonna wait to this run and start the deploy, and then we're gonna jump into what this is actually doing. Usually takes like 30, 40 seconds.
Did you write this Terraform? Or?
Yeah. There's not really much to it. You'll see. And I debate on that. I wanted to make this full fledged, like having logging and all sorts of. And I was like, okay, ultimately I'm just showing off MRSK here, not showing like how to make the perfect system. I think y'all will be able to take it from here. There's definitely room for improvement. So okay, we launched a bunch of stuff. Now let's go and MRSK setup and get that going, because I don't know how fast the RM, because it's kind of complaining about that. And make sure this is starting to go before I talk about it. Okay, so let's do another show.
You have to get the deploy lock on every single server.
I don't know for sure. That's a good question.
What was the question?
Does it get a deploy lock on every single server? I believe it would, but it may only on the primary. Like I said, there's one considered the primary, which I think is the first. And so if everyone's using that as way to get the lock, then it's probably I would probably guess that. But
You can change the primary.
yeah, you're looking to break this thing as much as you can, aren't you? Okay, so let's zoom in on this. So this is my 5-minute network diagram here. So internet, Mastodon actually has 2 web services it runs. One is everything, and the other is the streaming API. So I just created 2 load balancers. You could probably do 1 load balancer, look at host headers and direct traffic accordingly. But again, for simplicity, got a private network. We got our database. We got a Redis cache server here. We got our web cluster that's going to be serving off web requests. We got that streaming API server, that's what the streaming load balancer is going to go between, and then we got some background jobs that are going to run. So that's things you could do, like improve on this. I say private network, and they are all communicating by private network, but I'm also going to give them all public IP. If you wanted to do this better, you'd probably create what they call Bastion server, but that's the server you proxy through, and MRSK supports that natively, where you can say proxy through this server to deploy it, so then all these don't have to have a public IP. The downside of that is they have to talk out to the internet, right, to install Docker, which means that Bastion server you also have to set up to NAT out to the internet. And again, it got to be like, yeah, this is good enough. I didn't actually set up bucket storage on this. It's something I realized later after. I was like, oh, I guess so. When you upload files to this Mastodon, it's going to store it in one of the web processes, but you'll get the idea. Let's see. You probably want logging and monitoring. I didn't put any of that in there. Also, with the databases, just a single database, not high availability. You could do that. Same with Redis, just a single Redis. You could do high availability if you wanted. Let's see how our deployment's doing. Okay, still compiling. So next, let's talk about the actual configuration here. Mastodon, and hey, I get to put it in the actual config directory. You don't have to give it that -c option. Okay, this was. I realized this was stupid later, but in order to get IPs, so my Terraform applied roles to, here's the web, here's the job. And so then I was like, okay, IP for web, IP. But of course, every time it does that, it's calling hcloud. And so that's actually why when I run MRSK, it takes 4 or 5 seconds before it starts doing anything, because it's actually showing out 5 different times to Hetzner to say, hey, what's the IP for this? Hey, what's the IP for this? Hey, it would have been better for me just to run that once, get all the IPs divided up. But you'll get the point. So that's just a little thing to get the IPs, stuff we've seen before, multi-arc. So this is new here. This was talking about roles. So by default, there was a web role. So if I didn't specify any roles, if I just had servers and then hosts, that it's just using the web role. But we have multiple roles. We have our web, we have our streaming, we have our worker. Web by automatically assumes it's web, so it's going to put that traffic in front of it. Everything else it assumes may not have web. And so if it does, like this streaming, you need to say, yeah, I want traffic on here. Like the worker here, it's a background worker. He doesn't need web, so he doesn't get that. For the health checks, I'm doing a custom command, and I actually copied a lot of this from the Docker Compose that came with Mastodon, so that it looks fancy because I just copied and pasted what they had. But that way I didn't have to add curl because they already had wget, and so that worked out fine. Let's see. So Node app for the streaming. This looks familiar. Environment variables. Here's our Reddit host. Again, I'm using my little thing there to get that private IP for the Redis database. Database configuration. Here's where I messed up and meant to come back and add S3. And by S3, it could be any S3 compatible, so that Backblaze or whatever. But I didn't do that. And then secrets here. There are a few secrets that Mastodon has. So let's see. And Mastodon already actually does some .env stuff. So again, that stuff. So these are the secret bits that. And by the way, these secrets aren't put into the container. So you're actually safe putting this up on, like if it was open source code and you wanted to put it up on a public directory like Docker Hub, that's fine. The secrets live in this file here that you don't check in the repo. And then when they connect to the via SSH and they go to launch that container, they're going to pass it as command line variables. In fact, if you saw in the logs there, it actually said redacted on any of the secrets. Environment variables that aren't secret, it puts it right out there, making it easy to debug, but the secrets are redacted. Let's see, how are we doing? That's cool. That's push up. It's like a 500 meg container, and so I wasn't sure the speed here, but so this is interesting here. It's mounting from my WordPress one, even though I don't have any reference to the WordPress in this. I must use the same base container and part of the Docker's caching thing. I'm not sure. I thought that was weird. Let's see. I guess while we're waiting on this, any questions about what we're doing here and or about the setup in general? Let me go back to the config file here. Big deploy to YAML. And if you have any specific questions about this part, or if we're just waiting for the cloud.
I do have a question.
Sure.
So I have no idea, nothing about Ruby, to be quite honest. But I see that you have, I'm assuming that's Ruby code, like this dynamic part to get, all this, IPs there.
Oh yeah.
So you can just dump Ruby into this like YAML file.
Yeah. So it's using ERB, which is like the PHP version of Ruby, and so everything within those brackets just executes as Ruby. And by the way, there's a nifty little command line if you install ERB, or you could alias it just like MRSK if you wanted. But ERB config deploy.yaml. So if I just run this, it's going to run that, and so that's a way to kind of debug your code there. And you can see here, it's grabbed those IPs that I've specific out. So that's a nice way to debug rather than your command line. Just run the ERB. There's a CLI program called ERB.
It's like preprocessor.
Yeah. Still pushing. We're getting further. We only got like a little bit more. So, any other questions?
Are you using this in production?
No, that was actually that's actually a great question, and something I meant to mention at the beginning when I was asking about anyone heard it. And is no, I've been exploring this because I've traditionally used platforms. PAAS, platform as a service. Heroku is the OG one. My work's now on Google App Engine. I've played with Render and Fly, and those are great. But I like on Google App Engine will work. I all the time run into limitations where I'm just like, I just wish I had more control, and that's tempted me over to Kubernetes is probably the sort of obvious answer. If I haven't been willing to take that step because Kubernetes scares me a little bit, and so no, I'm joking. I don't mind learning it, but and I have played with it some, but it's a more of a question of we have a small team, limited resources. Is that something we want to bite into managing it, or do we want to continue hobbling on the platform, Google App Engine? And when this came along, it seemed like, okay, well, maybe this is where I can gain control, but still have something simple, because I did, run into issues while setting up these demos, and it was great because I could just see those commands it was running. SSH run the command. I'm like, oh, I first did set this up with a Bastion server, and then I was like, oh, I don't have internet access to these private servers. That's too much work. So I'll just give them all public IPs. But being able to shell in and run the Docker install and see that it complained it doesn't know what Docker.com is, that helped me see what the problem was. So I think that simplicity, we're almost there. That simplicity really helps with debugging, and that might be a reason why I will probably be using it or looking to use it in the future. And I'm kind of curious. That's partly why I want to do this presentation. Is I'm kind of curious people who have other experiences of me. I'm looking for you to say, hey, what about this or what about that? Because I'm hoping you'll tell me something that I can think of that maybe I need to consider before telling my work, hey, let's move to this cool new thing that just came out this year.
Well, let me ask the question. Has anyone used this yet? This is new to everyone that's here. Okay, cool.
Isn't it like June that came out? Or was it May?
I think.
Oh, really?
I think April was but that may have been more like commits were in April, and they may not have announced it till later. I don't know.
Well, I did notice it said 0.17.2 or something.
Yeah, it's not even version 1. I have a feeling that at Rails World they'll announce version 1.0 along with Rails 7.1 that has like that up endpoint and stuff. Hey, it's going. It's almost done now. So yeah, let's see, running.
For the control thing, you mentioned since you're on Google, you might look at Cloud Run instead of Apple.
Yeah, Cloud Run came out after we moved. I think it came out after we moved to Google, and I looked at that, and that might be something. But one thing I liked about this is also, we were on Heroku before this, and we moved to Google App Engine because basically Heroku wanted to charge us a lot of money for BAA because we do medical stuff. And having that cloud agility, I think, is important. Because maybe at some point in the future, Google will say, well, we got rid of Google domains. Let's get rid of GCP. No one's using it. And, we need to move somewhere else. For some reason, it's not working. And so since this just requires IPs, it doesn't care what region, what cloud, what you're using. And so that sort of appealed to me. And I think that kind of appeals to probably why I thought to present it with the Linux folks is because the Linux folks kind of don't like that embrace, extend, and that locking end of a vendor. And so it's almost done. It's checking some health checks on these different servers here. So it should be doing any second now. All right, so let's go over to Hetzner. Hey, look, we got a bunch of servers. And actually, let's go to the load balancers. I didn't give these domain names or SSH, but I could have. That's another area. So I'm going to actually hit the web first. And yeah, so no SSH. Yeah, and then there's our Mastodon. There's no data in it, but now we can take over Twitter or whatever. Yeah, X, yeah. We could also hit the streaming API, and it's going to probably say you don't have an access token, although we could come down here to this health check and just borrow that URL. Just see that, it's okay. Now, if I wanted to scale this up, say this is the Greenville Mastodon or whatever, and we're getting ready for a big event, and so we want to scale this up. We can go over to our infrastructure and we can say, okay, well, we got 2 web servers. Let's make it 3. Let's make 2 workers, and the streaming server will do 2. And this won't take nearly as long because now that's already pushed up a lot of the layers. But let's see. Big form apply. So this is just going to spin up a little bit more. And this adds it to the load balancer as well. So how we doing on time?
Yeah, I think the stream died about half an hour ago.
Oh, I yap too much. Maybe I had too many demos. Okay, we'll wrap this up, but you sort of get the point. We're gonna deploy. We're gonna increase the servers, deploy again. I made a mistake here. I realized after doing this, though, I should have put my infrastructure in its own repo, because now I have to commit it, which then gonna make it build a new image. If I was smart and made it a separate repo, then I could have just deployed, give it that -p option to pull down the same container I already have built, and it would have done it better. But we can do MERS server bootstrap. I think we need, because we need to set up Docker on the ones that don't have it. And then we can deploy again. It'll put it on there. And then if I want to scale back down, I don't actually have to do anything on MERS. I can just delete those containers. I can go to my Terraform, delete those containers, because there's no state, there's no database, there's nothing. It just will zap those, remove it from my load balancer, and that's all I'll need to do. So I think that's, you'll see the logical conclusion of this. I won't hold you longer. I don't know if there's any questions on that last bit.
Can you check to see if the stream is still live? My battery died on.
Oh, okay. Yeah, there's still people on here, it says. So I haven't bored everyone off yet.
Yeah. What is Mastodon? What's the streaming service for?
For the streaming API, I imagine it's for their probably app, or I don't know, but it's. Yeah, I actually don't know. I mostly just, like I said, copied and pasted. If you look at the deploy.yaml I set up and you look at the Docker compose.yaml, they're very similar. I copied and pasted a bunch of stuff from there. And
what I use to set up the Federation.
Yes.
Yeah, that's probably, yeah, I bet you're right. I bet it's related to the Federation stuff. So.
This is so much better than DHH's version of the demo that I saw in the video.
Oh, yeah.
That was so fast and so short. You did so few things.
Yeah.
This showed a lot more complexities and things you could do with it. So thank you.
Okay, yeah. Yeah, his demo is good. He fast forwards through some parts to try to not make it too boring. And he does show that destination where you go on staging versus whatever. So if you want to see a little bit more, check out it's 5-minute video, so it's worth
5 minutes.
Yeah, he just flies through it. That's what I said. I really wanted to see more detail on this.
Also,
a lot of like Capistrano influence.
Yeah. In fact, if you look at the MERS webpage, it says this is Capistrano plus containers. It's definitely influenced by Capistrano with the roles and everything. So, if you like that imperative style of Capistrano, but there's no server prep with Capistrano. You did have to install the Rubies and stuff. This it's going to install Docker. You just a bare Ubuntu, Red Hat CoreOS, whatever you want. I did want to real quick though say thanks to OpenWorks for letting us use this space. The co-working space here. So they're great for that. And also thanks to Simply Binary for the pizza. Didn't want to forget that before it.
Thank you.
And they've also been supporting the Ruby group and Elixir and tech stuff, both OpenWorks and Simply Binary for since before I moved to Greenville. So it's greatly appreciated. I guess I'll turn it back over to you since I've talked enough.
Well, thank you so much, Eric. We really appreciate it, don't we? Well, Ben, we'll see y'all later.
Okay, see you, Jace.
It's like, I'm going to bed.